Okay. 5 out of 17. Okay. So first was to confirm. You told me that already received the email that I sent, right?
Yes.
You have the other sent? Yes. So before execute. Okay. So welcome to our spring semester course of the computer vision. First, let me introduce myself in case you don't know me. My name is Ahmed Sayed. I'm an associate professor of electrical and computer engineering here at UB, and I will be an instructor for the computer vision for this semester. Let's start first by introducing the course, what exactly we will cover for the course. So all our material and all the things that we work on will be available through the Canvas. So first thing, I want to make sure that all of you have access to Canvas, right? So I'm not sure why you are sitting all of you in the back. You can come to the front. We have many electric plugs here. If you are looking for electric plugs, this room has so many electric plugs. So let's go through the course together on Canvas. So first thing, I'm not sure if you used the Canvas before, but in Canvas, you will see the taskbar here, which has all the available options. The first one here for the assignments. If you click it, you will find all available assignments new, including the due dates and all the required submission and the tasks. Of course, now there is nothing, but I will add one by the end of this semester. Then the discussion, in case you have any questions and you want to discuss something with your other students or with me, you can add it here to the discussion. But I prefer the direct email to be better. From the grades section, you will be able to see your grades for all the assignments, including the attendance. And I'll come to this point in a second. From the people section, you will be able to see all other students you have in the course. And you will need this at some point when we talk about the project. Then for the files, you will see anything that I'm uploading here, including presentations, material, code, and anything we will use. For now, there is nothing, not many things, but the most important thing for us right now is our class syllabus. So before we start, I want you to understand or hear from you what's your expectation from the course. What do you think computer vision is?
Recognition of faces which will be used for tracking.
I'm sorry, say again?
Recognition of persons which will be used for tracking in terms of defense sector.
Okay. How about you?
Making the computer able to detect and classify them.
Okay. What do you think computer vision?
Yeah, detecting the regions of the computer and different.
Okay.
Allows computer to recognize and understand the visual content.
Okay.
The way computers analyze images, photos, like that, visual stuff.
Okay. Actually, all what you said is correct, but to just conclude it in a more generic form, so we can say that the computer vision is a branch in science, or to be more accurate, in computer science or computer engineering, that deal with images and video streams. So if you have any system and this system has input as an image or video, in this case, you are dealing with a computer vision problem. Okay? So we are trying to give the computer eyes like the human. What are the purpose of this eye? We will see in a second. We can use it in so many applications. So what you said is a subset from what we can do. Okay? So in this course, we will focus on how we can analyze the images or videos to extract information that can give us better understanding for the scene or from this video stream. The course will take place here in this room every Monday from 4:30 to 7. Just to give you a small warning from the beginning, unfortunately, Mondays in the spring is a tricky day. We will lose some lectures, okay? Including next week, as an example. Next week is Martin Luther King Day, so no lecture next week, okay? So to recover this missed lecture, from time to time, I will post some videos for you to watch by yourself, some recorded lecture, so you can go through them that will cover some topics in our curriculum. My information, as you can see here, this is my phone number, this is my email. Those are my office hours. I'm available during those office hours every week. If none of them work for you, just send me an email and we can set up different time for appointment. Okay. Do we have textbook for the course? The answer is no. Why? Because this course is changing rapidly. While we are talking right now, there are some place in the world changing one of the algorithms that we will use. Okay, so the textbooks, unfortunately, are not up to date. All the textbooks considered to be old, even if it's published 2024, still old. Okay, but we can have two books as a reference, not as a textbook. Those books are the Computer Vision, Models, Learning, and Inference for Simon Prince. The second one is Computer Vision, Algorithms and Application for Richard Sadlewski. Okay? This one is more comprehensive and it's recently published. This is the second edition, 2022. But unfortunately, it includes paragraph about every algorithm that we'll cover. So if you read it, you will not find a detailed information about the algorithms and how they are working. Okay? That's why I can't consider them as a textbook. The good news is those two books are available for free. They are open source, available online. Okay? I'm including file called book links here, which include the links of the two textbooks. If you are interested to download them, you can find them from here. From this one, you need to register your account, create an account there and register it, and they will send you a watermarked version for you, so you can use it by yourself. You can sell it, you can share it with anyone. And unfortunately, I can't share any of those material on Canvas for the copyright purpose. But you have the rights to download the books by yourself if you are interested to have more information about those two books. It's available on Canvas, you don't have to take any picture. So if you go to the file section on Canvas, you will see text file called Booksling. Okay. Let's back to the syllabus. Okay. As I was saying, we will use or we will implement and learn about several algorithms that will solve so many problems in the computer vision. Algorithms means implementation, means programming. Okay. So here we will use programming techniques to implement those algorithms. The official programming language that I will use here in the lecture room will be the Python. Okay. Here's some other resources for the Python, including PyTorch, the Python link, the OpenCV, PyTorch, and Anaconda, and so many other things. But if you are familiar or you feel comfortable with using other programming language, please let me know. Like someone may have background in MATLAB and he feel comfortable using the MATLAB to do the work. I'm okay with that, but you have to let me know. Okay. So if you feel comfortable with Java, that's okay. If you feel comfortable with C, which I doubt that any one of you feel comfortable using C. Anyone here like using C? I don't know. You will need it at some point. So you can use whatever programming language you would like to build the algorithm without any problem. For all the algorithms that we will build it from scratch, meaning we will not use any toolboxes. So even if you use the MATLAB, it's not allowed to use any of the MATLAB toolboxes. You have to build the algorithm yourself. That's what we will do in the Python here. That's why the usage of the OpenCV library, which is the open source computer vision library, is prohibited. Okay, it's not allowed to use this library for now. At some point, I will allow you to use it when we build the foundation for the course. Okay, when you are ready and you learn how to build the algorithms yourself, in this case, you can use the OpenCV. When we go to the advanced higher feature, higher level feature, extraction and matching. But for the first couple of assignments, using OpenCV is completely prohibited. So if you use by any chance the OpenCV, your assignment will be graded as 0. Okay? The course evaluation is divided into those 5 parts. There is 10% loaded on the attendance. So if you are not attending the lecture, you are losing 10% of the course mark, plus you will have some troubles with the school system. Okay? The assignment will have 25% load. There will be a midterm and a final, each one of them. One had 20%, the other one is 25%, and there will be a project which will load 20% of the final grade. The project will be on one of the state-of-the-art recent published paper in the field of computer vision. That's why I'm including the link of 2 websites which consider to be the top-notch conferences or societies in the field of computer vision. The first one is the Computer Vision Society, or the Computer Vision website. This institution is holding or hosting or supporting so many conferences, including the CVPR, the ICCV, so many, okay? And it has all the state-of-the-art publication in this field. The other one, the MIPS, which is ranked #1 conference in the field of machine learning, computer vision, AI, and pattern recognition. This one is more theoretical conference. So it has so many papers, but it introduced new concept in the world of AI and machine learning. You will need those at some point when you start to select your project topic. Here, as you can see, there are so many topics we will cover during the semester, including small introduction about the images, what is the image and how we can handle the image with the computer, going through feature detection, line detection, corner detection, the features like SIFT, SURF, or ORB, the RANSAC algorithm, all of those things. Then how we can make feature matching. I give you two images. Can you match them to find similar objects in the two images, or build extended version and stereo vision or view for the scene. Then, when we come to this point, we will go to one of the state-of-the-art techniques we have in the field of computer vision and machine learning in general, which is the neural network. We will cover basic concept of the neural network. Again, I'm not assuming that you have any pre-knowledge about the neural system, so I will start from scratch. Then we will learn about how we can use them in the computer vision, how we can handle video streams, how we can detect objects, how you can segment the image, find the required information, detect objects, whatever. So many concepts that we'll cover through the semester. As you can see, we will cover so many topics here, and most of them, not all of them, part of the computer vision and the machine learning topics, or part of the AI, modern AI system. Now, are you allowed to use the AI by yourself? The answer is no. Okay. So you need to be familiar with the cheating rules or ballarings, where if we have any copy, unauthorized copy from specific source, or copy from your colleague, or using the AI, all of those are forbidden in the course. And the rules of the school is available here in this link. You can go to this link and read all the entire rules. Actually, using the AI will hurt you more than improving your learning. So if you want to use the AI to understand something about a concept or figure out something that you're missing, I may tell you okay, but don't ever trust the AI. AI is not giving you correct results in many cases, okay? One of the recent paper published about the AI systems, especially the chatbots, you can do this test actually yourself when you go to the ChatGPT. Try to write the word strawberry. How many are in the word strawberry?
How many eyes?
R.
R's? This one. Three.
Three.
Yes, three.
Strawberry. So double R, right? Enter this question to ChatGPT and see what will be answered. It will tell you two. So the AI has so many problems, has so many limitations. So don't ever trust it.
One.
Give you one? Good. So it go to KG1 again. So this is one of the problems of using AI. AI has so many problems and confusion when it's making decisions. Okay? So don't trust the AI ever. Okay? Whatever that
Choose with two.
that's what I got. And for him, he got one.
Yeah.
So, yes, it's intelligence, but still artificial.
Yes.
Okay? It's not natural. So it can't give you the correct decision about many things. So don't trust it. Good luck. You are using ChatGPT, which year? Okay. Yeah. For him, he got two, I got two, he got one. So, anyway, even with that, this means that there is no consistent output. Okay? So he's giving you something, he's giving you another thing, and the two information are contradicting. They are not the same. This means that the outcome of the algorithm or the AI system is not consistent, it's not correct. Okay? And that's exactly what will happen if you are asking the AI to write a code or implement algorithm for you. It will do the same exact thing. We'll give you something, we'll give him another thing. Okay? But all of them will be consistent together. So it can't repeat itself. Okay? And repeat the same result again. And the output, you can't trust it's correct or not. Okay? So using AI will hurt you first because it will not give you correct results. This is the first place. Even if it gives you correct result as an output, you will not learn. Okay? If you are relying on AI to get a job, then good luck. That will not happen. When you are doing a job interview, even if it's online, you have to have share your screen with a whiteboard shared between you and the examiner, and you have to write the code and do everything yourself. If for 1% the examiner think that you are using the AI, congratulations, you'll be terminated. Okay? And it happened before in many jobs. While they are taking the phone call, they found that the responder or the one who was making the interview didn't give the correct answer because he gave the answer inside large sentence like this. The answer should be one word, but he telling or saying or answering in a paragraph. So why you are giving me paragraph? I need one word. Yes or no? This or this? If you give me a paragraph, this means that you don't understand what's going on. And mostly you are getting it using the AI. Okay? Plus, our systems here have an AI detector. Okay? So if you are generating anything using the AI, it can be detected over the camera system. And if this happens, zero. Okay? So please don't use AI and try to learn the things yourself. If you spend the time and try to work on these assignments, you will learn. And that's the final outcome I want from you, to learn. Okay? We are here available for you to assist. I'm providing some office hours. There will be TA to assist you, and you will also provide some office hours, so you can stop by anytime, ask any question that you want. If you don't understand anything or you can't handle any problem, we are here to help. Okay? This is the main goal of any course you are having here, learning. If you are not learning, then the output is zero. Okay? Again, this syllabus available on Canvas. Of course, I didn't print it. It's available there in the soft copy in case you want to read more about the information in it. Okay. Again, as I said, the official programming language that I will use here during the lectures will be the Python programming language. That's why I'm having a folder here for you, including a simple tutorial about using or how we use the Python. The easiest way to use Python in your academic life is to create a separate, isolated environment for your course. Because if you are using only one Python environment for all the courses, the packages and libraries will interact together and it will end up by a disaster. You may come to the final project with the project not working. Okay?
Also,
So,
can I come in?
Are you with the computer vision?
Yes, sir.
So this concept is similar to other concepts actually in the computer engineering. The first one called the container. Any of you heard about the container concept? No? Okay. Any one of you heard about the Dockers?
Sir.
Okay. The concept of Docker is exactly similar to the concept of container. So you are trying to create isolated environments to run this task without interacting with the other. The same concept actually designed or implemented by Apple in their iOS originally, and they are trying to extend it for other applications, which is called the sandbox. So any application you have on your iPhone should be isolated from the other applications. It has its own memory, it has its own flash, it has its own everything, and isolated from the others. Okay. They thought initially if they did this, they will isolate the applications from each other, which will protect you from viruses. But unfortunately, people found another way to do the problem or to give you troubles. So it didn't work well with them, but they're still using it. The same concept we can apply also here. That's why we will use an environment called Anaconda, not the traditional Python. Okay, so don't go to www.python.com and download the official Python version from there. No, it's better to go to the Anaconda website and download the Anaconda environment. How to do that? You need to go here. Download Anaconda distribution. Then, for me, I don't like to register, so skip registration. If you want to register, of course, feel free to do that. Then you can download the suitable Anaconda for your system. If you are using Windows, if you are using Mac, if you are using Linux. Anyone here using Linux? No? You're using Windows and Mac, right? Okay, so you can download the Anaconda Python for both Mac and for Windows. For Windows, it should not be a big trouble, should work smoothly. For Mac, good luck. Because unfortunately, Mac has now 3 architectures, or even more. The old Intel, M1, M2, and M3. So it's 4 actually. And each one of them has different performance from the other. So some people face some troubles with versions that the others didn't face. I'm not using Mac, I'm not a Mac user. So I will not be able to help you much with that part. The good news is that TA is using Mac. So hopefully he can assist you if you have a problem with your Mac device. If you are using Windows, you are more than welcome to ask me about anything. Okay? Or Linux, of course. I'm a Linux user. So I know how to handle it with the Linux. With Mac, it's a little bit tricky because also the security. So when you download the application, make sure that you enable the package to be secure package. See, they have different versions. Some for the Silicon Apple and the other one for the Intel chip. So depend on your device. You have to be aware what are the characteristics of your device to install it. Okay. Most of the modern ones should use this. Silicon Apple, which is M1, M2, M3, any one of those, the 64 bits. Okay. If you have older Mac version that use the Intel processor, in this case, you need to use this one. So you are the one who should decide which version you are using. Okay. For Windows users, very simple. Okay. Even for Linux users, it's very simple. We can use this one. Okay. you did so, when you go to the apps, you will see the Anaconda Python available here in your menu. If you press it, you will have the Anaconda Navigator. While you are installing the Anaconda, there is a small tiny thing you need to watch out for. So those are the instructions. Include or activate this option. Okay, this and this option. Okay. Sometimes, or some people say it's not good to activate and he give you some warning. I'm not sure about the newer version, but if you didn't do that, if you try to run the Python directly from any command window, it will give you a problem. So that's why it's better to activate those two options. Okay. Once you did so, again, you'll find all the entire instructions here, starting from the installer until you finish the installation. 1 second. Yeah, it's just loading. If you open the navigator, if you open the Anaconda Navigator, you will find here environments. If you press it, it will give you the ability to create your own environment or open the pre-existing environment. By default, you will have the base environment. This is the default one that occurs for you once you download or install the system. If you want to create new one, simply go here and write the name of your environment. Let's say computer vision environment or computer vision course, whatever you want to call it. Then make sure you mark the Python to use or to download, or you have a specific version of your Python. Then choose the version according to the recent install, because this is not a new. The newer one will give you 3.12 Python version. Okay. For here, I'm having 3.11. Okay. Watch out, because at some point later, we will need 3.7 or 3.6. When we go to the higher dimension features, we will need older versions, because some problems occur in OpenCV with that. That's why it's only compatible with the older Python version. But for now, you can use 3.11 or 3.12 without any problem. Okay? Once you press create, I will not create one again, already created one. So once you press create, it will create the environment for you and include the basic libraries. Those basic libraries, including the core Python libs, including the PIP, which is the package installer, including the PIL, which is the image handling, and some other basic libraries. Unfortunately, those are not enough for us to use. So you have to press this sign and open a terminal. If the terminal open correctly, you will see terminal like this, which have the name of your environment next to it. Okay? Now you have a safe virtual environment to install any libraries that will be compatible with our course. If you are having another course like deep learning, reinforcement learning, advanced deep learning, data mining, whatever the other courses, you will have their library there that doesn't conflict with this course library. Because conflict occur. This is unfortunately a problem that we have in Python. Okay? So the safest way is to have an isolated environment. What is the drawback of this technique? The hard drive size. Every time you are creating environment, it creates a newer environment, including all the libraries for you. So this is a redundancy from the environment, but it's more safe. If there's any problem occur in one of the environments, you can easily delete it without losing the other coursework. So we will go here and try to install the newer or the other required libraries. What are those other required libraries? Actually, I'm including them here in the installer. So you need to run pip install user, numpy, scipy, matplotlib, pandas, sympy, and nose. Those libraries are required, especially the numpy and scipy, matplotlib. Those are mandatory and will require for our work. Let's go through them one by one. The first one is the numpy. NumPy is a library created for Python that gives it the capability of the MATLAB. What does this mean? Anyone work with MATLAB before? Okay, what is the power of MATLAB?
It's like an online. It's kind of similar to what you were saying before about the isolated instance.
Mm-hmm.
But it's like an online version of it where you don't have to download anything. It's all on the website.
Okay. Is this the main power?
All the libraries.
Yes.
Has all the
So
libraries.
the libraries and the matrix. So MATLAB actually stands for matrix laboratory. So any single element included or any variable we are creating in MATLAB is a matrix. Okay? So the NumPy simulate or cover or convert this concept to the Python. So this NumPy library will give you the capability to work with the matrices exactly as you are working on MATLAB. Matrix addition, multiplication, division, or inverse. All of these algorithms included here. So you don't have to deal with all of these problems. SciPy, including some advanced algorithms for optimization, linear algebra, and some other functions. So it's very important library as well, because we'll use it through the work. Matplotlib is the graphical interface library, meaning if you want to plot any figure, you will need the Matplotlib. 2D, 3D, show image, anything, you need the Matplotlib. Pandas is library specialized in the data sets or tables. So using the pandas, you can handle any data by any problem, without any problem. So this one is compatible with the NumPy and SciPy. SymPy gives you the symbolic math capability, meaning I can write a symbolic equation and it can solve it for me, okay? Which is again required by those libraries and OpenCV later, as we'll see. Those also, you provide some parallel computation that will require for both of them. The good news is when you do this, it will install all required Python library for your coursework. So this one command will do the entire task for you. How I can check if my environment works well or no? First, I just need to write Python. It will give me the Python version that I created. As you can see, this is an older one. So I created 3.7 to make it compatible with the feature extraction. We will come to this point later. And of course, the creation date and all the required information. Then inside here, I can import any of those libraries that I just installed. to make sure it has been installed correctly. So for example, I'm here checking the NumPy, no errors, then it has been imported correctly. Okay, I can do the same thing with the SciPy. No problem. Matplotlib. No problem. So everything is good with me. The most important library that you will need for the first time is the library called PIL, which is picture, the picture library, which you will use to read the picture from the hard drive and extract the information for it. So from here, I will import PIL to make sure if it's included or not. See, no error, needs included, which come by default when you create the virtual environment. Okay. So this is the first thing we need to check on our machine. If you are not familiar with the Python or you didn't use it before, here I'm providing 2 tutorials. Leave this alone for now. About Python programming and how you can use it. Okay. Now, as you can see, we didn't use any IDE to write our code. For now, we only downloaded the Python programming framework or the interpreter, but we didn't find or we didn't use any specific IDE to write our code. The usage of the IDE, I leave it for you. You can choose any IDE or Python IDE from your choice. There are several Python IDE versions available. One of them, as an example, is the Visual Studio. Some people like to use Visual Studio for Python editing. It's up to you. If you want to use it, you can use it. Some people like to use Microsoft Visual Code. Again, it's up to you if you want to use this one. Some people like to use the one come with the Anaconda. Which called Spider. This one. Spider IE. This one looks very similar to the MATLAB. So if you are familiar with the MATLAB environment, this will be good start for you. Okay? Myself, I prefer Eclipse. I prefer Eclipse system. Okay? But again, this is my personal preference. That's what I feel comfortable using it. I'm not asking you to use it. Feel free to use any environment from your choice. If you decide to use the Eclipse, in this case, you need to use a library called ByDev. ByDev environment, okay, which is an add-on you can install over Eclipse that can support the Python, because by default, Eclipse is not supporting Python. If you are familiar with Eclipse, Eclipse has been designed mainly for Java. That's how originally it is, okay? But they introduce other programming language to it. So now it's good with C if you want to work with C. It's good. So PHP, any other programming language, including the Python. But you have to include the add-on for the programming language you will choose. Okay? Depend on the IDE that you will use, you can configure the environment or the virtual environment that you choose. For example, here in the Eclipse, after I'm creating the project, so if I'm creating project, ByDev projects, from here, I'm configuring my environments. So I can choose any environment of my choice. Okay? Where are the environment located? The environment originally so this should be the download folder for the Anaconda Python. Inside this folder, you will find folder called envs. Those are the environments. So here you will find all the environments that I'm creating. And of course, the one that you can create as well. Okay. So you can register the environment with your IDE based on your choice. So this is the first thing that you have to decide with the course. What IDE you will use, because you will stick with this IDE from now, and of course, which programming language that you will choose. So I'm working with Python. If you feel comfortable with other programming language, you have to decide, but you have to let me know, okay? Because the grading will be according to that. Any questions so far?
What about Jupyter Notebook?
I'm sorry?
A Jupyter Notebook,
What about it?
it's an IDE, right? So can we use it?
Yes. Okay. So Jupyter is one of the alternative IDE. It's good and bad at the same time. It's good in one thing, that you are writing the code and you can see the result just next to it. So the notebook file, including the code and the results. Okay? The bad thing about the Jupyter, that you can't have an output, which is something we are looking for here in this course. We are, as we will see in a second, when we define the computer vision, we said that the computer vision, meaning I want to give eyes to the computer, meaning I'm applying input image and I'm having some output from that. If this output, for example, is a modified image, meaning that you have to save it, Jupyter will be not good with this thing because it runs as a web browser, or you run inside the web browser. So saving images from the notebook is a little bit challenging. And also changing the environment in Jupyter is a big challenge. You have to write some command to configure the new environment in Jupyter. Okay, but it's not impossible. If you like to use this IDE, again, I have no problem. But once you finish, to show you how to do it. Once you finish your code and you have your output, generate Python file from this notebook. So don't submit the notebook itself. Submit the generated Python output and the output images as required. Yeah, so the Jupyter, when it's open in something like this. When it opens, I'm creating a new file. So the notebook file have the extension of IPYN. Okay. After you write your code, any code that we will write here, and press run, we can execute this section and we'll see the result here next to it. Okay. If I want to generate a Python file from here, I can press File, Download as. Does it? Python. Okay. So this way, whatever you wrote here, it will be converted to a Python file, .py file, that you can submit for your work. Okay? The only good or advantage of using the Jupyter, maybe later in the project you will find it, that it will help you use another environment called Google Colab. Anyone familiar with the Google Colab? So Google Colab is nothing but similar environment like the Jupyter. You can write your code and you'll see the result next to it. So it's the same exact notebook technique. Okay, so you can upload your notebook to Colab or download Colab, the notebook from the Colab. But again, if you are working with Google Colab, you need to do the same trick to generate the Python file. Okay, so the final submission for the assignment and for the work should be the Python file and the output image that I'm asking you to generate. Okay, so please don't give me results here in the notebook. Okay, this is not good. Any questions so far? Any problems? Okay. So those are the two books I was telling you about. This is the first book of the computer vision algorithm application, and this is the computer vision models learning and inference. Again, those two books available for free. You can download them, the soft copy, of course, from Canvas. But again, we are not using any of them as a textbook. Those are good references. Okay. Now, let's now go more into the concept of the computer vision. So the first question that I asked you at the beginning, what do you think computer vision is? And each one of you said something about what you're expecting to learn in the computer vision. And I told you that computer vision is all of this combined. So computer vision, as we stated, is the techniques of simulating the human eyes. So we are trying to give an eye to the computer. And based on that, we can generate some decisions. What's the difference between computer vision and computer graphics? Can you tell us? What's the difference between computer vision and computer graphics? Any idea? I didn't explain it actually. I'm just asking you for your opinion. Can you please stay with us? Yes.
Vision, like you said, is what you see with your, is what the computer would see with if they had eyes. And then graphics is what it will present to you.
Very close. So computer vision, as we stated, we have system that has image as an input, as we'll see the description for the image later. So this is the image, and this image applied as an input to the computer vision system, and based on that, we can make some decisions or some output, whatever this output is, even if the output is another image. Okay? The computer graphics, on the other hand, produce image even if the input is not image. Maybe there's no input at all. Okay? So the output mostly synthetic, not real. Okay? So this is the main difference between graphics and vision. For vision, I'm reading image as an input first. Okay? Then I'm processing it. I may add to it, by the way, which is similar to what, like if I have now a picture for the room here, and I added a dinosaur here, virtual. What is this? You know what this means? I think you saw it in many things. Any one of you interested in the gaming?
Object, augmented reality.
That augmented reality, virtual reality and augmented reality. So I'm reading image as an input and I'm modifying it. I'm adding some extra objects to it. Even if those objects are virtual, they are not real, hypothetical objects. So this is considered to be computer vision part. Why? Because I'm having input as an image. I'm modifying it, I'm having output as a synthetic or another version from it. But if I'm not having any input from that, and I'm generating a completely synthetic image that's not related to the real world, this is the graphics. And actually, both of them work together. So many algorithms from the computer graphics shared with the vision, or vice versa. Okay? But we will not go through the computer graphics here because it's a completely different topic. How you can generate the render an image on the GPU and all this stuff. It's not part of our course here. So for computer vision, we are expecting the algorithm to build something like this. Of course, you know this, right? Anyone doesn't know what it is?
Terminator.
Yeah. So it's a highly functional robot or highly functional computer, something that have eyes and it can make decisions based on whatever he can capture with these eyes. Those eyes are nothing but cameras. Okay? So that's exactly what we want to achieve here in this course. Capture some images with the camera and make decisions exactly similar to what we can do in the real life. So you can see exactly what are the scenes for that. For the anyone watch the movie? Especially part 2. You watched Terminator 2?
It's a classic.
Yeah. Anyway, so what we want to achieve by the end of the day is telling the story. If the computer see a picture, it can tell us what's happening in this picture. What's the scenario going here? So for you as a human, if you look to this thing, you will say what? Train had an accident and came out of track and destroyed the wall, come to the street. Okay? Now, can the computer tell the same story that we just said? The answer is maybe. What?
That has the right background information.
It's exactly what we want to learn. Can we give the computer the capability of telling this story? Until now, we had limited capability. So with all what you can see right now, from the technology of the computer vision or the machine learning and AI, we're still trying to give the computer this capability. So at the end of the day, we want the computer to tell me that we have train, and this train did accident, hit the building, crashed and hit the ground or the road, and they are trying to survive or help the people in this train. So different factors that we need to find from the image to tell this story. Now, what exactly the computer can see? So when we give the computer this image, what exactly it can see? Love. So it can see numbers. The computer just see numbers. nothing else. So it will see array like this, or matrix to be more accurate, that has bunch of digits. Now, the magic occur when we convert those digits into information useful that we can extract from those images or from those numbers. That's exactly what we want the computer to do. Convert those numbers into information. Okay? And that's exactly what we want to handle here in the computer vision. So, if you look at this cell, what you can see?
Abraham Lincoln.
Okay? Do you think the computer also will see Abraham Lincoln when it analyzes? Mostly no. It will see bunch of numbers, as we will see in a second, that it will analyze to find the information. And those numbers actually are those. So this is the image for the Abraham Lincoln. Okay? Now, can we relate those to those? That's what we'll learn maybe today. Okay? So, our goal, again, as I said, this field of the computer vision is not done. It's still one of the very hot topics in the research. And while we are discussing right now, some people in some place in the world are changing the algorithms. So it changes almost daily or every hour. And you can easily find this if you go to thearchive.com. I'm not sure if you know this website or no, but this website considered to be repository, just website. People add the research to it before publication. Okay, so any research on this website is not trusted. Okay, but it can give you indication about what exactly people are doing in this field. Okay, but again, don't trust any research here, because many people fake the research. So this is not 100% trusted. This is handled with caution. That's why for your project, as we said, don't bring any paper from here. The paper must be published in good or high reputation conference or journal, because publication means reviewers. There are some scientists specialized in this field, read the paper and review it and give their decision if the work is correct or no. Okay? Here, no one is reviewing anything. Just people adding the work. Okay? So don't trust information from here. So our goal is try to train the computer, or not train, learn or teach the computer if it can extract information from this to become to the level of the human. But the question is, can it beat human? The answer is maybe yes, maybe no. In some tasks, actually, yes, the computer vision already beat the humans. Like what?
Calculations.
I mean the vision. There are some computer vision tasks where really the computer already beat the human. Anyone know an example?
Traffic management, sir. Counting the number of cars,
Counting?
the vehicles.
Okay. This is not really. Still below the human level. Actually, you will be surprised in the human detection and recognition. So the machine now can detect and recognize your face better than the human. There are so many landmark data set has been tested on machines and on humans. The machine get better accuracy than the human.
Facial recognition.
What?
Facial recognition.
Yes. Detection and recognition, both. Okay? So there are many tasks where computer now become better. but not all every task. And I will give you one good example that the computer is still far behind in this task, which is the driving, autonomous driving. You as human, what are you using to see the road and make the decision while you are driving? Only eyes, right? Do you use any other sensors? Except the horn, if someone make a beep for you on the horn. Rather than this, only the eyes, right? Until now, no technology used only 2 cameras to make autonomous driving. Nothing. The Tesla company, which the company, their technique relied 100% on the computer vision. So if any of you see a Tesla car before, Cybertruck or whatever the model that you check, you'll find that they didn't have any other sensors for the environment checking, only cameras. And they have mostly about 6 cameras all around the body, okay? And they still can't achieve 100% autonomous driving, okay? Unlike human, we have only 2 eyes and we can have fully autonomous driving because we are the driver, right? So in some cases, the computer could beat us, in some others still can't, okay? Will it be able to do that in the future or no? We don't know. Yeah. So in this case, as an example, are those 2 pictures for the same person or no?
Very close.
Who said yes? Who said no? Okay. Actually, no, they are not from the same person. But most human or many humans fall in this trap. Okay, so when they look to them, they think, especially if they are away from each other. So if I give you this picture first and give you this picture second, you may say they are similar from the same person. Okay, for computer, no, the computer could distinguish between them.
It has different numbers, obviously.
Yes, but we are not working absolutely with the numbers here.
Okay.
We are extracting some information other than the numbers we'll learn later. Okay. Now, how about this? Is it moving or still?
Steady.
It's still. But it looks like it
Which is illusion, actually.
is.
This is one of the very well-known illusion problems. So for you, you may see it as moving objects, but for the computer, it will see a bunch of numbers. The number position is not changing, right? So for computer, 100% still. But for you, no, because you can't. For our brain, it's tricking us, so we can't think it's moving. Okay. So I can see that you moved your glasses because you got illusion. Okay. Now, what exactly the state of the art right now in this field? Actually, we have computer vision now available around us in many ways. Like we are using it in daily application, like this. You know what it is? So, your Zoom now do background subtraction automatically, right? This is a computer vision problem, which is called segmentation. So we are segmented the body of the person, subtracted from the image and added to another image. Okay? This is done in all of your computers right now. And I'm not sure if you're aware or not. This is done using the neural system. So there is a small tiny neural network in the Zoom application that do this task for you. That's why when it has been introduced, I think it has been introduced heavily in 2020 during the pandemic. And there had some restriction on the CPU to run it. So if your computer is not Core i5 didn't run well. After that, they tried to make it more public, available for all computers. I'm not sure now if it's available for the Core i3 or no. But this one is one of those tasks. Using maps. maybe you saw it or no, I'm not sure. But there are so many cars going around US, maybe out of US also, for companies like Google and Apple, collecting information for the streets, street views. Okay, did you see any of them? So those images or videos are collected and stitched together to build a panorama view for the scene. So you can go to the Google map and see a panorama view for the scene, or it can give you a 3D view for the buildings and the streets. All this is a computer vision. And you will learn actually how to generate a panorama view for the image from here. Okay. Also the 2D map and navigation. It still use the for both Google and for Apple. Of course, all of you now using the Insta and X and Facebook, where you can easily identify the picture for yourself or for your friends and upload it. And now in modern phones, you can even remove someone standing on the back. You can easily wipe him, right? Sorry?
Apple Intelligence.
Yes, and it's including Google as well. So all of these are computer vision applications. And in modern devices, both in computers and phones, we know that those computers have two types of devices, which are the CPU, which is used for the general calculations, and have GPU, which is used for graphic rendering and high dimension data. There is a newer processor also available now in most devices called NPU, Neural Processing Unit, which is a small tiny device just designed to run neural networks. And it's available in all modern chips. So all those Apple devices have the NPU over it, okay? And all modern phones include the NPU with it. So it can do all these tasks without any load over the CPU and the GPU, okay? This is one other application. You know what it is? Black hole image. Actually, this is not an image. This is a synthetic image. This is not a real one. The image that has been captured using telescopes on a very high or different frequency range. Okay, so they change the frequency range to the visual one, and this generated to simulate the actual view. Okay, so all of these are computer vision algorithms, and the people used to this specified the algorithm they used to generate this view. Most of us right now can have a 3D view from a 2D. So we can apply regular image as an input, and from this image we can generate a 3D view for some specific theme. When I say 3D view, I mean a real 3D. Because in the views we have different categories. The first one called 2D. 2D means I can see a projection, assuming my eyes is a surface and the view is hitting this surface. Okay, this is the 2D projection, like the regular image that we have in our life. There is something called 2.5D. What is the meaning of 2.5D? In this case, I can see the pixel and I know the depth of the pixel. Okay, so I'm having the pixel value and the depth, how far from me. But if I rotated the scene, I can't see the back. That's why it's not a real 3D. It's 2.5 only. The full 3D means if I rotated this object, I can't see the back. This is a pool scene. Okay, which is exactly similar to the one we have in the Google Maps and the Street View. We are generating a full 3D scene, not only 2.5. Okay, so now this becomes trivial, and you can do it using so many applications nowadays. Similar to this, we have so many other applications, like the aging application, of course. Did you use it before?
Snapchat.
Yeah.
Yeah, it was a trend at some point. So you can generate yourself younger or older, all of these computer vision applications. This is one of the most challenging problems. I'm not sure if you know this problem or no. Did you hear about this problem? No?
Oh, this isn't even a real person, right?
No, it's a real person.
Is it the girl from Afghanistan?
Yes. So this picture has been captured for this girl in Afghanistan since I think the late 70s or early 80s. Okay? And it was an iconic picture for some time. At 2011, I think, they tried to identify the same lady again in Afghanistan. And unfortunately, they couldn't until they found her. That's her now. And the only way to identify the person, in this case, using the iris. The eye. Because if you use the face here, the face looks completely different. Like, this person is completely different from this person. Okay? But the eye has a pattern that has not been changed over time. Okay? So, using the authentication and the authorization and all the biometric identification techniques included under the computer vision problem with the fingerprint, face, iris, retina, anything. All of those, by the way, there is a retina detection, so you can have a scan for the inner of your eye, which can be used to identify yourself. Okay? Gate detection. Did you hear about the gate detection before?
Gate?
Yes. So while you are moving, there is a gate for your
Oh, okay, in the airports,
I'm sorry?
I mean, the security check you've done.
No, there is no, okay.
It was there in.
Entrance checks, right?
Mission Impossible.
No, it's identifying your walking pattern.
Mission Impossible 5.
Sorry?
The techno was used there in copy of Tom Cruise.
Oh, yeah, exactly. But it's not theoretical, and it's not only for the Tom Cruise movie. No, it's really available. So there is a branch in research for the gait detection. It will detect your walking pattern or your running pattern. So it can identify you from your back. You don't have to have your face or anything, just the way you walk. Okay? And that's why they always now tell you, don't capture a video or image for yourself with something that people can identify. Like what? Like this. Don't do that. Because with the super resolution technique, I can take this image right now and extract the fingerprint. And I can use it. Make another copy and I use it against you. Okay? So don't do that. Okay. There are so many restrictions right now on using or when you put your information online. One of the restrictions is the deepfake. Did you hear this word before?
Yeah, deepfake.
Yes.
So I can remove or use this picture and add it to another scene, video, just by one picture. I don't need more than one picture to do this job. Okay? So computer vision now has so many problems or challenges. People use it in the correct direction, and another people use it in the wrong direction. Okay? So using it for object detection, again, this is one of the trivial information on the task that we use it for. And of course, you have it now on all your phones. I'm sorry?
Google Lens.
Yeah, and not only for Google, for Apple as well. We also use it in Hollywood. Okay? I'm not sure if you are familiar with this, but one of the biggest research lab in the field of computer vision is Disney.
This lab.
Yes. Even they are considered more as graphic company, so they should be concentrated more onto the graphic work. But no, they are very active in the work of computer vision from many perspectives. Okay, so Hollywood considered to be one of the big place for application for the computer vision, used in so many applications. So this is one of them, the Matrix, and this is also one of the recent movies which has been created 100% using computer vision. So Robert De Niro in this movie has been the movie called The Irishman. I'm not sure if you heard about it or not. Usually, a long time ago, if they want to put the actor back in age, younger, they put some makeup or some face effects over himself physically to can be younger. In this movie, they didn't use any of those makeups. So the scene has been captured this way, and using the computer vision, become like this. Yes. Okay. So computer vision now included in many ways or many applications. One of them is the sport. I'm very sure that all of you have something with sport, like baseball, soccer, tennis, whatever the sport that are using. You can see now the tracking for the players, the tracking for the ball, finding the offside as an example for the soccer. There are so many applications for that, and there are some big companies with a big budget just for that, and they are using lots and lots of the computer vision applications. Of course, the gaming. Anyone know the Kinect?
Yeah, I got it.
Yeah, it has been stopped a long time ago.
Yes.
But actually, I like it. Actually, it's one of my favorites.
No new games coming.
Sorry?
No new games coming anymore.
That's a legacy version.
Ah. Who will develop something for all technology? This is the problem.
But it's like comparatively they got that Nintendo. We have to take that gadget in the hand and we have to play. But that's not more flexible than this.
Yeah, this one is better.
Yes, that's what I'm talking. Yes.
Actually, I'm not sure if you're aware about the story of the Kinect, but the company has been sold to Apple,
Mhm.
and Apple killed the project
Yeah.
intentionally, which is one of the problems actually for the with the technology. Some bigger company buy the smaller technology because this project actually started by a startup.
Yes.
Okay, and they have a collaboration with Microsoft, so Microsoft didn't own them. They just sell them the product, the controller. Apple bought it and killed it, considering it, or they assume or they consider to include it in their modern iPhones. That's why in the modern iPhone, they're using the same technology used in the Kinect, which is the 3D projection. They project bunch of infrared beams to your face to generate the 3D view of your face, which is exactly the same concept of that. Okay? But now we have the modern gaming consoles, which is the virtual reality and the augmented reality. And the HoloLens, I'm not sure if any one of you worked with the HoloLens before? Yeah, I know it's expensive. So HoloLens is one of the goggles developed by Microsoft, and it's the state of the art of augmented reality. So if you are wearing the goggle, you can easily involve yourself into the world. So they are using it in many industrial applications, unlike the Apple glasses.
Decode holograms, right?
I'm
You
sorry?
can decode holograms also.
Yes, okay? And it can detect your hands and you can interact with the objects, okay? That's why it's used in many applications, actually in surgery, you can do a surgery online on this. Okay, it's a really very good one. So this is the architecture of the Googles. Okay. Okay, and of course, augmented reality, where we can project this information to. There are some videos for that, but I don't want to spend more times. And if you're using these fitness applications, did you hear about the smart mirror for fitness? So it's a kind of mirror application that has cameras and some sensors which will detect your body movement. So you are doing some practice with the weights or whatever the training that you have, and it will track your body. Actually, this is a video. What is it? Okay. This is one simple example for this thing. Okay, of course, we don't have to forget the NASA and the space work. Okay, all the rover that has been sent to the space are equipped with so many vision algorithms for navigation, for tracking, for analyzing the environment. So it has so many applications around, and of course, the autonomous driving. Okay, as I was telling you, most modern cars use vision to go through the environment. So if I want to classify them, the autonomous cars now have two categories. The first one using the vision, like the Tesla one, or they are using fusion of sensors, like most of the other companies. Like what? Like the LiDAR, cameras, IMU, inertial measurement unit, infrared, and so many others. So in both cases, the cameras and the vision algorithms are included, where we want to achieve an autonomous driving that can compete with the humans. And there is also one of the companies that specialize in this, especially in the 3D data collection, which is the Waymo. If you don't hear about it, they are providing the data, by the way, for free. But you need to have a good hard drive to have it. One sample is 10 gig. It's too big data. And of course, including drone, the time lapse, 3D rendering, and using the neural network for the object detection, which is something called YOLO. Anyone hear about the YOLO before? Do you know what it stands for? You only look once. Similar to the movie. Okay? Actually, there's a movie called that. You only look once. And there is another one, you only live once. But this is one means you will look to the image, just one view, and with one processing cycle, you have to find all the objects in the image. Actually, let me show you a small example for that. Yeah, I have it here. Sure, we'll cover this model later in the course. Okay, sorry, it's my fault. What? Oh. I'm running the camera on this and I'm trying to run it. My mistake. Yeah, here we go. So I can run and detect the objects in my environment in almost real time. So if you can see, I can detect how many objects in about 100 milliseconds. So frame rate is about 5 to 10 frames per second. Okay, and this is on a computer that has no GPU, no NPU. So it's a very simple computer. Of course, if we have an NPU or a GPU, it will work much more efficient. Okay, and it can active or detect so many things. So it can detect this laptop. Actually, not sure whose laptop is that. Yeah, it's yours, I think. It can detect me. It can detect you. I'm not sure if it can detect the others. All of you have been detected once. And this output happened in one cycle. Okay, that's why it's called you only look once. Because with one view to the image, I will detect every single element of every single object that has been trained for. Okay, that's why this algorithm is very efficient.
What does the number mean?
It's the confidence.
Confidence?
Yeah, so it think that I'm human with 92%. Okay. Okay. So yeah, that's exactly what we will go through during the course. So at some point, we will learn how we can use the neural network for data analysis, image analysis, for classification, for object detection, for semantic segmentation, how we can segment the image, separate the object from the background, so we can identify the object for detection, the architecture of the network, all of this things that we will learn in the object. And of course, there's something called style GAN, which is used actually for the deepfake. This is the architecture, the hidden architecture for the deepfake, the style GAN. Even this is considered to be a little bit old because there are new techniques nowadays available with the diffusion model that can be much more efficient than this one. But this one is still in usage actually. Anyway, so that's basically what we will learn through the course for this semester, including all those applications from the generation to identification to the detection, ending with the neural network and how we can write codes with something called PyTorch, which is a library for the neural network architecture. For that,
Like AI.
right, but I don't like to use the word AI because AI,
It's not specific.
right, AI is a big umbrella. So what we have now with that we call AI is something called chatbots. Okay, this is the only function of it. Okay, if you want to discuss or talk about the AI is a big umbrella that has so many things underneath. Okay, now we are talking about, or we will discuss in the research, we are talking about something called artificial general intelligence. Something that can do anything. Model that can handle vision tasks, that can handle natural language processing tasks, something that can handle audio, video, anything. If you achieve this, then we have an AI, an actual AI. What we have right now, still limited, okay? So I don't like to use this word, but the more specific or more correct term to it is just deep learning or deep neural system, because we are trying to imitate the human brain. However, the human brain is working, we are trying to do similar tasks, okay? Any questions? Actually, this is one of the things that we will learn also. So do you think, what is this image for? For that?
Beautify the image.
What
I mean, beautify, sir, enhance the image.
No, I'm asking you who the character in the image. Okay, can you close your eye a little bit?
A woman,
A woman, a girl.
it's a combination of two pictures.
Actually, it's Marilyn Monroe,
Yeah.
okay? So this is also one of the things that we will learn here in the course, how we can combine and filter the image to generate output that mix between them, okay? Using something called Laplacian pyramid. So this is covered whatever we will cover, we'll use for this course. Anyone have any questions? Okay, let's take a small break. Let's say 10 minutes, and we'll return, we'll start, because as I said, next week we have a break. Unfortunately, it's Martin Luther King, so we don't have time to waste with this lecture. So we'll start after the break, okay? Okay. Uh, uh, the understanding of the image, as we stated, to can extract information from a given image, the first step will be to read and understand the image contents. Okay, and that's exactly what we will go through for now. But before we do that, this is just the information for the TA for the course, or the GA. His name is Hemant Kumar. I'm not sure if he will be the only one or we add one more. Maybe we can have another one, but he's the one we have for now. If you have any question, you can contact him, and he will also add it to Canvas, so he can help you with the assignment grade. Okay, so now we have a camera, and this camera captures an image. What exactly is the image? So the main concept of the camera is box that has lens, and this lens collect the rays from the environment and reflect it back to the back here, where we will have a small tiny sensitive film that affected by those rays and produce the image. This is the classical view for the camera, which is called the black hole concept. And this experiment, actually, some students still using it or still doing it in middle schools or high schools. They can build a house of wooden box and have a small tiny hole in this box where the light can come through this small tiny hole and reflect to the back. If you look to the back of the box, you can see the image of the scene. Okay. This concept actually was the original concept for the traditional camera that used to define long time ago. When they come to the concept of digitizing or introducing the concept of digital camera, they said, I want to have the camera as digital numbers. They achieved this by small tiny modification. What is this modification? They said, I will replace the area after the lens with a sensor. So we will have lens, and after it, we have sensor. When we collect the data through the lens, it will be reflected to the sensor and trigger it. This triggering will generate number. This number will represent the image. Okay, so each ray will generate a number. The question is, how many rays we are collecting from the environment? How many rays your eyes can collect? Actually infinite. Okay, because each light or each bulb from those produce infinite number of rays. Okay, so we have lots and lots number of rays. Can we collect all of them here on this sensor? They said no, I can't do that. That's why I will try to collect as much as I can, and I will build this sensor to look like an array or a matrix. So this sensor actually look like this. Some chip that has lots of transistors. When the ray hit the transistor, it will be converted to a number that will be stored in the memory. Okay? And physically, if you hold it in your hand, that's how to look like. If you have some Canon cameras that you can change the lens, if you remove the lens, you will see this view actually behind the lens. Yeah. Okay, so this is nothing but chip, and it has lots and lots of the transistors. Each transistor is photosensitive. Once we collect, or when the ray hit the transistor, it will open a gate and store the amount of illumination it received and convert it to a number. So this is array or matrix. Each one of them will produce number. So the image at the end of the day will be transformed into, array of numbers. Each number represents one sensor. We are calling this sensor a pixel. Okay, so the image is nothing but matrix of numbers. Each one of this represent one sensor, and each one of them called pixel level. Okay? Now, if we consider it as a number that has dimension, this means that I have to deal with it as if I'm dealing with the matrix. Now, any matrix has some properties. What are the properties of the matrix? How you can describe the matrix?
Based on designated values,
Okay,
prefix values,
okay.
rows and columns.
The size, which is the dimension, number of rows and number of columns. That's why the image also will be handled as the matrix, means it has number of rows by a number of columns. Okay, so when we describe any image, we are describing it by how many rows it has and how many columns. And that's exactly what we have in our cameras and the screens. When you buy or you go buy screen, you will ask about the resolution of the screen, right? Which means how many pixels it has. Okay, which is the exact dimension of the screen. Okay. Now, this makes sense. But how I can distinguish between the colors? Can this one single number per sensor distinguish between the colors? The answer is no. That's why we divide the image into two categories. Grayscale and color. Grayscale means I'm working with the data with no colors. I have only gray levels. In this case, the matrix or the image will be 2D. Land. Just one dimension, or sorry, 2 dimension. Have rows and columns. Each pixel value will have a number. What is the reflection of this number? What is the meaning of this number? This said, I will give number 0 to represent the darkest color in the gray level. What is the darkest color in the gray level? Black. I will give 255 to represent the lightest color in the gray level. What is the lightest color? Settling the 0 makes sense. No problem with that. Okay? Why 255? What's that? 2 what?
2 power 32.
2 power 32.
In binary 256.
2 power 32 is 56. 256. Anyone have any idea?
The rays getting into
I'm sorry?
the rays getting into.
I mean,
No, I'm asking why 255?
each color has.
Why we didn't use 1000, for example? Why we didn't use 100?
I guess that's system for white color specifically.
Any thoughts?
That's
I'm sorry?
255. Is that something to do with like the color spectrum?
Did you see this pattern before?
Yes.
The least significant bit and the most significant bit? What we call this? Byte. 8 bits. Okay? So 1 byte have 8 bits. Right? What is the minimum number can be held in the byte? Minimum.
0.
0. What is the maximum number we can hold in the byte? 2 power 8 minus 1, which is what?
Yeah.
The 250. So every single pixel here is stored in a byte. Okay? So the pixel values are nothing but bytes. Okay? Can we have more than that? Yes, but depend on your memory usage. But the typical configuration for the byte, sorry, for the pixel is 1 byte. Okay? This is the typical usage. 1 pixel equal 1 byte. That's why we have 0 value for the black, 255 for the white. As I said, we can add more more bits or more bytes, like we can use 16 bits, or you can use 32 bits or 64. But in this case, we will have more spectrum or more shades, gray shades in between. Okay? Which is doesn't require in many cases. So now, on this definition, we can estimate the memory size for the image. If I give you a grayscale image, can you guess what is the size of this image?
Megabytes.
Or whatever unit. How you will do that? I can easily multiply the number of rows and the number of columns. This will give me the total number of pixels. And each pixel requires 1 byte. So 1 times all of this will give me the size of the image. That's how we typically calculate the size of the image. Okay? So assume this image is 600 by 300. What will be the size of this image?
0.8 MB.
1.8 megabyte. Okay? It becomes trivial now. I can easily calculate the size of any image if I know its dimension. This is only for what? For grayscale. Using which codec? The 1 byte codec, the 8 bits. Okay? If you change this, or you change it from the grayscale to the color, this calculation is not correct. Okay? You have to adjust it. Any problem so far? Okay. How about, so now this is the image. It will become a matrix that has dimensions. So for example, this image has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 by 14. So it's 14 by 14. Actually, it's 12. 14 by 12. 14 row.
1.68.
Okay? You can easily calculate the storage size of this matrix or this image by multiplying this times this by 1 byte. You can calculate the size of it. Okay? How about the color? How can we store the color? We said, let's go a little bit to the arts. What are the 3 basic colors that if we combine them, we will have any color in the palette? Those are one of the bases, but not the only ones. So there are so many bases actually. If you are working with arts, you will learn that there are so many bases. If you combine together, you can achieve any color in the palette. But the minimum required number of bases is always 3. You need at least 3 colors. Nothing less than that. Okay? That's why they decided to represent the color image as 3 layers concatenated to each other. So for the color image, I will have 3 layers that represent the image. Each one of them is a matrix. So the first one, matrix by itself, which has M by N. The second one also M by N. The third one, M by N. That will give us a 3-dimension image. So the grayscale image is 2D. The color image is 3D. And the third dimension is always what? 3. M by N by 3. Now, what are those 3 layers? As a typical selection for the computer vision application, they decided to use the 3 bases R, G, and B. Red, green, and blue. Again, are those the only way to describe them? No. Okay. Some people, for example, remove the green and put yellow. It will work. So there are some other combination which you can use, but the typical one for the computer vision application is this one, RGP. Okay? Are they always with this order? The red first, then the green, then the blue? The answer is no.
Depends on the light rays, right?
Sorry?
It depends on the light rays.
No, depends on the way you want to store it. That's it. So the typical is RGP. That's how we always write it. RGP. But some libraries preferred BGR. Some say I want BRG. It depends on your selection. But the only thing that's typical, that the B represents that the blue components, the R, the red components, the G, the green components. So the basis is not changing. So if I want to convert from this to this, I will switch the layers. If I want to change from this to this, I will switch the layers, which means switching those layers. That's it. But the image itself is the same. Okay? So this is one representation for the color image. So the grayscale image is a 2D matrix. The
Color
image is a 3D matrix, means we have third dimension. Okay? This is the only view for the image? Unfortunately, no. We have another view. He said, what if I'm assuming that this is the origin? If this is a matrix, the coordination of this point will be 0 and 0, right? Then 0 and 1, 0 and 2, 0 and 3, 0 and 4, right? Those are the names of the element in the matrix, the 2D matrix, right? This is similar to coordination in the 2D space, right? So I will assume that this is the x-axis. And this is the y-axis. And this point here is a function of this coordinating point, which means that this function of 0 and 0, this, as an example, this will be function of 3 and 3. Sorry, 4 and 3. Of 3 and 2. Because here 0, 1, 2, and 3. Keep jumping. And here 0, 1, and 2. So function of 3 and 2. Okay? In this case, I can describe every single pixel here as if it's a function of the location. Can I interpret this mathematically? Yes. In this case, the image can be represented this way. So in this case, I will have x-axis here, y-axis here, and the pixel value is a function, which means I can make it a 3D view to look like this. So if the value is light, like white, it will be high value. If it's dark, it will be low value. So this is just the same image. So the image become what? Become function of x and y. So this is the second view for the image. First view as a matrix, second view is a function. Function of x and y. The two views are important. The first view, which is the matrix, is important because we can apply all matrices operation on the image, including all the algorithms of linear algebra. If I want to make addition, I can. If I want to make subtraction, multiplication, inversion, anything I can do to the image. Why? It's a matrix. But will the matrix view will help me understand and enhance the image? Unfortunately, no. For example, I want to enhance this image to see this dark area in a better way. Can I do that from the matrix view? To this one, regular one? The answer is tough a little bit because I need to add value to the pixel, which is not something that I can do with the regular matrices. But if I look to it as a function like this, I can generate another function, which is g of x or y, which equal f of x, y plus 3, as an example. Newer function that equal the older one plus 3. Now it become regular math problem, okay? So having the function view for the image can help me enhance it, do so many operations on it, like adding some value to it like this. This means I will come with every single pixel value and add the value 20 to it. So now I'm posting the gray level. So it was dark, I will make it lighter. Remember, 0 means black, 255 means white. So if I add value to the darker, it will be whiter. Okay? I can inverse it, reverse, flip it around x-axis or y-axis by just changing the value of x and y together. Okay? Become a function. You can play with it however you would like. Okay? From this concept and from this perspective, we came up with a technique for image enhancement. What do you mean image enhancement? I want to change the value of the pixels to be more visible. Okay? So I need a technique, mathematical technique, that can make the objects, for example, more visible. Like here, as an example, I want this eye to be more visible. Now I can see this eye clearly, but I can't see this eye? No, because it's in a dark area. Can I enhance it to be more visible? One technique, we call it the alpha beta technique. What is the meaning of that? Listen, I will generate a new image, which is the G. So this is the original one, which is F. The G of X and Y will be equal alpha F of X or Y plus beta. So I can multiply those pixel values times something, then add it to another variable to achieve a newer enhanced version. Like what I have, exactly what I'm doing here. So here, the value of alpha will be 1, the value of beta is 20. Okay? This technique can change the image from lighter to darker or vice versa. But is it always correct or good? Let's see. Let's go to the example we have here. This one as an example. So those are white, which equal what? 255. Now let's apply this formula for over it. So g of x of y equal f of x y plus 20. In this case, the generated g will be, let's make a small sample here. Just for the first couple of pixels. The 255, when we add the 20, will be
275.
255, 275. Again, same thing. Here also the same thing. This one will be 40.
40.
This is also 275, 275, and also repeat. So this will be 40. This will be 20. This will be 90,
95.
and so on. We fall on a trap now. What is this trap? Remember, when I told you we are using one byte to store the pixel, what is the maximum value can be stored in these bytes?
55.
Can I store 275?
No.
We follow the trap. The value after adjustment over the limit of our
It can be
storage.
250.
Sorry?
I mean, it can be 255.
We need to make clipping to it. Actually, what happened here right now, something called the overflow problem. And the overflow, if you are not aware of it, can reverse or convert the number to negative or even zero. Okay? So here, this whiter color can be converted to black because of this problem. Because the size is 8 bits and I'm adding more. So it will be overflowed and become back to zero. Okay? So now I destroyed the image. That's why the concept of the alpha beta adjustment can be good if the image is all of it dark or all of it light. Because the adjustment I will do will be applied on all the pixels of the image similarly, so it will put all of it up or put all of it down. So if it's all dark and I add 20, it will make sense to improve. But if we have some white colors or white parts, it can be damaged if I did this. Okay? So this technique is not that good. Can I have another technique that can enhance the quality of the image and preserve the condition of maximum 255? They said, yes, we can do that. What is it? They said, I will use the same concept. G of x and y equal f of x and y with some mathematical operation. But what is this operation? First, what is the maximum value I can achieve in the image? I will divide the value of f of x over it. This is the maximum value I can achieve, right? So any value from the pixel, which go from 0 to 55, will be divided over to 55. The result from this operation will be what? Integer or fraction?
Integer.
Fraction.
Fraction,
Yeah.
because this is the maximum I can achieve, right? When I say fraction, means the minimum will be 0. When f of x, y is 0, the value will be 0. If x, y equal to 55, the maximum will be what? So it will go from 0 to 1, nothing more than that. Okay? Agree? What if I put this with the power half? Function to the power half. It will do what? Fraction from 0 to 1.
It will blur the image.
Let's test it. Assume this fraction is half. Oh, sorry, 1/4. Put it power half. So it will equal what?
1/8.
It will 1/4. We take the square root. 1 power half means square root. So square root of 1 is 1. Square root of 4, 2. So it become 1/2. Did it increase or decrease? It has been increased, right?
So how it increased, right?
I'm sorry?
It got increased, right?
Yes, increased.
No, sorry, I mean decreased.
Okay.
But it was
The original ratio was 1/4.
Water.
After we take it power half, it become half. Which is bigger, half or 1/4? So it increased.
okay.
Okay? Now, if I multiply it now times 255. So it was 1/4 times 255. Equal what?
27.5.
We calculate. 255/4. Yeah, it was 64, almost. So the original f of x and y equal 64. Oh, so 63 something. Assume. Okay? Now, after I do this operation, this will be 1/4 equal half, so it will be 255/2, which is 128. Sorry. So it equal 128. Now, the value of the pixel increased or not? It was 64, it become 128. So it has been increased. Within the limit or no?
Within the limit.
Can it go over the limit? Why? Because of this normalization. So the first normalization step will preserve and guarantee that the output will never go over the limits. Okay? So this is a good example if I want to increase the value of the pixel. What if I want to reduce the value of the pixel? What exactly I need to change in this formula to reduce the value of the pixel? It was 64, I want it to be reduced. What exactly I need to change?
The 1,
You need to be what?
2.
Exactly. So instead of having here fraction, make it integer or greater than 1. So if I change it as an example to 2, in this case, this will be 1/4, power 2 will be what?
1/8.
1/16.
1/16.
Okay? 1/16 times 255 will equal? It's 16. So this way we reduce it. That's what we call it the gamma adjustment. By changing the value here, and we call it gamma. So you will have g of x and y equal f x and y over 255 power gamma times 255. So the selection of the value of gamma will enhance it by increase the pixels or reduce the pixels. But it will guarantee that the value of the pixel will never go over the limit, which is 255. This one can't guarantee. This one will guarantee that will never go over that limit. Is this clear?
Yeah.
Any questions? So those are two techniques for the image enhancement. Okay, and we are using them a lot when we are adjusting the image.
How do you take the gamma value?
I'm sorry,
The gamma value,
what about it?
you took 1/2, right? To the half.
Here in this example, I'm assuming the gamma is half.
Okay,
Here, I'm assuming the gamma is 2.
okay.
Okay, so the value of the gamma depends what I want to do in the image. If the value of gamma is fraction, the value of the pixel will increase. If the value of gamma is greater than 1, the value of the pixel decrease. If it's exactly 1, what will happen?
It will stay the same.
Nothing change. Because the 255, we cancel the 255, so g of x will equal f of x. Okay? Is it clear? Okay. Now, this is okay. This is good to enhance or to use to enhance the image. But what I'm doing right now, work on the whole entire image. Meaning, if the whole entire image was dark, it will be light. Or if the whole entire image was light, it will be dark. Can I work on some specific part on the image rather than the others? Like, can I enhance this dark with keeping this one?
To some extent.
If you go back to the X and Y plane,
Okay.
pick the specific pixel
How I will select those specific pixels?
by the X and Y,
So this means I have to be intervene or I have to input my selection, right? Can I do it without entering my selection? Can I have an automatic way to enhance it? Enhance some parts against the other?
anything that's less than 255.
Again, this is also my selection. For that reason, they found another technique which called histogram equalization. What is the meaning of histogram equalization? They said, me as a user, I will not select anything. I want the system to work automatically, detect the unrepresented pixel values and add it to the scene. What does this mean? They said, I will define something called histogram. What is the histogram? Histogram in math is the frequency of occurrence of a specific value. Meaning, assume that I have a list that has specific numbers. Let's say 10, 20, 15, 10, 20, 20, 15, 15, 5, 3, 20, 3. Yeah, that's enough. Okay? I can calculate for those numbers whatever we call the histogram. What is the histogram? The histogram is the frequency of occurrence of the number. Meaning, I will check the numbers available here in this list. What are the numbers available? Those are the unique numbers represented here in this list, right? The 3 occurs how many times? The 5, the 10, 1, 2, 2 times. The 15, 1, 2, 3. The 20, 1, 2, 3,
4 times.
4. And I will plot a graph for this frequency. So I will make a graph that has the x-axis are those numbers. So I have 3, 5, 10, 15, 20. And the y-axis is the frequency of occurrence of those values. So the 3 occur 2 times. So here at 2. The 5 occur 1 time. The 10 occur 2 times. The 15 3 times. The 20 4 times. And this graph will be called histogram. Now, if we assume that our palette that we are selecting from this list, including the number from 0 to 20, do we see all the numbers here on this line? Do we see number 0? Do we see number 1, 2, 4, 6? No, none of them represented. The concept of histogram equalization say, I want the others to be represented exactly as those. Even if each one of them will represent it once, I don't care. But I want to see representation for all the number or all my choices here on this axis. Okay? That's what we call histogram equalization. Meaning, I want this graph to be flat as much as I can. The ideal histogram is flat, straight, okay? Which we can't have actually. But we are trying to represent other numbers here that also occur, but we didn't see it here. Meaning, I will try to replace some of those numbers with other numbers that didn't occur before. Now, in math, does this shape ring any bells in your brain? Similar to this shape, the frequency of occurrence of something?
Yeah. Statistics more or less like.
Right. In statistics and probability it has a name.
Median.
BDF, exactly. Probability density function. So if we divide here as an example over 4, which is the maximum number of occurrence, we will have this. So if we divide over 4, this will be half. This will be 1/4. This will be half as well. This will be 3/4. And this will be 1. We divide over the sum of all of them, we will find the final sum of them equal here 1. Like, what is the sum of all of those? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we'll divide everything here over 12. Divide every single number here over 12, which is the number of occurrence here, and sum all of those. The sum will be what? 1, which is the property of the BDF. Okay? So this can represent or similar to the concept. So let me remove that. Similar to the concept of the BDF we have in the probability. Okay? If only we divide over the number of samples we have, the histogram will be converted to a probability density function. Okay? Now, can I modify the probability density function to be more flat? They said yes, by doing the equalization process, which happened by calculating something called the CDF or the cumulative density function. Okay, so let's see how we can do this in the image. Assume that I'm having image that has those pixel values. Okay. Now, what's the possible value for each pixel? It can be vary from 0 to 255. Okay. Now, this image have only those values. The first thing I will do is calculating the frequency of occurrence of each single level here. For example, here, the first number here is 52. The 52 occurs how many times? Search the image. You will find that occur only one time here. So I will count, write the count for it. 52 occurred once. Next number, 55. Occurred how many times? I'm having it here, here.
We need 77.
Here. So 3 times. 58. Actually, let's get another color. Yeah. 58. Yeah, here.
And below 68.
We need 68. Third row.
Where?
4th row from the bottom.
Here. Okay, you have more? I don't think so. Okay, so I will try to find the frequency of every single gray level I have for the image. Every single one. And sort them. So starting from the smallest one, ending with the highest one. With the frequency of occurrence of each one of them. Okay? Any problems so far? Okay. Now, I know the number of pixels in this image. How many pixels in this image? 1, 2, 3, 4, 5, 6, 7, 8.
64.
1, 2, 3, 4, 5, 6, 7, 8. So this is 8 by 8. So it has 64 pixels. So now, if I divide every number here over 64, I will get the probability distribution of all those gradients. Agree? Now, can I equalize this to convert this histogram? Now, this is the histogram actually. Can I equalize this to get it more flat? The answer is yes. How? By applying this formula. What is this formula saying? It's saying, first you need to calculate the cumulative distribution. What is the cumulative distribution? Cumulative distribution means for everyone here, after I sort them, I will write the level with the frequency of occurrence of it plus all the previous. So this one occurred once. Anything before it? No. So it will become 1. 55. The frequency is 3. So it's 3 plus 1. So it will be 4. 58. It's 4 plus 2. 6. 59. 6 plus 3. 60. 9 plus 1. And keep doing this for all those levels. This value is the CDF. Okay? If you check it, does it by any chance go down? It always increases, right? So if you want to plot it, that's how it should look like. always increase. Okay? Until you arrive to the end, it will start to saturate. The maximum value in this table must be the number of pixels in the image. Must. Because it's the frequency. Okay? Can it occur more than the number of pixels? Okay? So, after calculating the CDF, I will make another table. The value I'm already having in the picture with the value I will replace it with. This replacement will be the output of this formula. Let's continue this next time. Okay? Any questions?
So what about the attendance today?
We'll take it right now.